Hello, all of you. Welcome back to this YouTube channel. Today, in this video, we are going to discuss about the strength of material. So, all of you, what is the strength of material? Here, before study about the strength of material, we will be discuss what is the mechanics. So, mechanics is nothing but the mother of all engineering science. Okay, so mechanics is the mother of all engineering science. So here mechanics is the three types. One is the rigid body, rigid body mechanics. The second one is the deformable body mechanics, and the third one is the fluid mechanics. Okay, so here in rigid body mechanics we are study about the force and motion of the body. It deals with the force and the motion of the bodies. Where deformable mechanics deals with the properties of the material, or we can say the properties of solid material. Okay, so here in fluid mechanics we are discussing about the liquid and gas. So here in strength of material, we are just going to discuss about the deformable body materials, which is related to the solid materials. Also, strength of material is also known as the mom. Mom means the mechanics of material. Here we have to study about the properties of a solid material that deals with. Okay, the load we can talk about, the important loads are the pull load and push load. So here what is the pull load? Pull is a load. Here you can see in this diagram, this is a body. When you apply force like this, similar forces are acting in the both hand. So this nature of force are known as pull force, or we can say the tensile force. Okay, so this is the very important. And next is push force. What is push force? Here you can see a body, and you just push this body like this by applying force. So this nature of force is in compression nature. So that's why it's known as compression force. Got it? Okay. So here you can see a body like this. Okay. So this is the original body. You can see the length of the body is L. Okay. And when you pull this body like this, then the we can say tensile force act on this body in the both hands. Tensile force. Okay. Then the body will be elongate. Elongate means its length will be increased. Okay. So here you can see this is the initial condition of the body. When you apply the tensile force on it, then it will be increase its length like this. Okay. Then its length is like this. So here length is increased. Okay. If you will push this body, if you will be push this body like this, then it will be compressed. This is the tensile force due to the tensile force. And if you will be compress the body by applying this type of force, compression force, then the body will be compressed. That means the length will be decreased. So its length is small, small s. Okay. So here only tensile force and compression force are acting in this body. And always remember the force acting on a body in nature of tensile or compression, we can say the force is always perpendicular to the cross section. Okay. Perpendicular means you can see this is the cross sectional area. Okay. Here the force is perpendicular. Means here the angle creates 90 degree. Okay. Always pull and push force is 90 degree. That means the load is always perpendicular to the cross sectional area. Okay. So this type of this type of force are acting, you can see here, this type of force are in perpendicular in nature. Perpendicular in nature means it create the 90-degree angle. Here also it creates the 90-degree angle. Okay. So here always we can say this load, if the loads are perpendicular in nature, then we can say what? We can say this is the normal load. Next, what is the shear? Shear, you can see this is a box. when you apply force parallel to the body. What is parallel? Parallel means you apply the force like that, and this is the force. So this parallel in nature of the force which is applied to the body is known as a shear force. Okay, or shear load. Always remember, here you can see the force acting perpendicular, and that perpendicular force we can say the normal load. Okay, which is always 90-degree at the cross section. Here talking about the shear load, shear force, then when the force acts on a body, this is the body. Okay, then the force is parallel in nature. Okay, the parallel in nature, then we can say this is the shear force. Coming to the normal stress. So what is the normal stress? So here you can see normal stress is denoted as sigma. Normal stress is denoted as sigma. Here you can see this is a body. Okay, when you apply load on this body known as P, the load is P, then this is the cross sectional area of the body. Okay, so this is the cross sectional area of the body. Okay, then what happened? Then we have to calculate the sigma. Okay, we have to calculate the sigma, means normal stress sigma equal to, we know that force applied P to the cross sectional area, to the cross sectional area. Okay, simply we can write force by area. So here P is the force is in Newton, and A is the area is in meter square. Okay, so it will be what? So it will be, we can write sigma equal to force applied by cross sectional area. Okay, this is the formula for normal stress. This is the formula for the normal stress. Okay, then how the normal stress develop? Here we are going to see. You can see a body like this. This is a body, and we are just applying a pull force to this body. Okay, so if we'll be apply force on this end and on this end, then it will be what? It will be elongate, and a internal resistance will occur in this place. So this is the middle portion of the body. When you pull this body, then the internal resistance will be formed. So that internal resistance will known as the stress. Okay, so here we can, you can see the internal resistance will want to break this body. So if the body will be break like this in two parts, okay, so this is the pulling force you can see, and the body is now two parts, and the body is applied force on this way and this in this way. So this nature of force we can say F1 and F2 are acting in this middle. So here this F1 F2 is similar to F. So here we are just writing a formula. You see what is the stress? Stress is sigma is equal to what? The internal resisting force by the cross sectional area. Okay, so here you can see the internal resisting force are F1 and F2. Okay, so here at the place of internal resistance force we can write normal stress sigma is equal to F1 and F2, F1 plus F2 by the what? The cross sectional area A. So here what is F1 F2? You can see here, remember in strength of material, whatever the force will be applied on a body like pull in nature or push in nature, the forces always in equal. So static equilibrium forces are acting on this body. So here F1 and F2 is equal to F. That's why internal resisting force F1 F2 we can write F. That F is equal to this applied tensile force F. So here you can see F1 plus F2. This is the F2. We can write F by A, or we can say P by A. So P or F no problem. You can write applied load as P, or we can write the F no problem. F and P are the what? Applied load on the cross sectional area of the body. Okay, so the normal stress sigma is equal to the internal resistance force F by the cross sectional area A. This is the formula for the normal stress. You can see here. Stress sigma is the what? Is the internal resisting force. Okay, and next the stress sigma, the second point is we can write it is tensor quantity, or we can say the tensor quantity is also known as second order tensor. Remember, this is asking in short question always in the different competitive exams. Stress is also a tensor quantity. You should remember. And this is the second order tensor. Okay. Then next is stress is always acting normally and parallelly. So normal stress is always perpendicular in nature. and parallel force is parallel in nature. Okay. So next is stress sigma cannot measure. If you will be asked, sir, stress has a formula sigma equal to force applied to the cross sectional area. So how can you will not measure the stress? So I know it's stress has the formula, but stress has not a measurable quantity. There is no device made till now to measure the stress of the body. Okay, so this is a not measurable body. Okay, this is a not measurable, we can say. So next point is stress sigma is not a property. Stress sigma is not a property. Just remember these things. Okay. Next one is the normal stress. Normal stress. Here a body is there. You can apply its tensile force or you can apply the compression stress that are perpendicular to the cross sectional area. Okay. So this normal stress is this normal stress is directly related to the bending stress. Okay, just remember the bending stress is due to the what? Normal stress. And the parallel force, parallel load or force act on a body. Here you can see this is the body. When the forces are acting parallelly to the cross section of the body, then this is the body. Then we can say what? We can say the shear stress, it will be developed, shear stress and the torsion or twisting. You just remember these things. Okay. Act normal stresses, then the bending stress generate, the bending stress is due to the normal stress. You just remember these two important things. So we know that stress sigma is equal to load applied to the cross sectional area A. So load P is always in Newton and area is always in meter square. So its unit, we can say SI unit is what? Newton per meter square. You just remember this thing. Okay, SI unit is Newton per meter square. This is the important. Okay. So next is what? And we can see here the difference between pressure and stress. So what is the pressure and what is the stress? Always remember pressure is the what? Pressure is the external force while the stress is the what? Internal force. Okay? And pressure is the scalar quantity while the stress is the tensor quantity. Always remember. And next, pressure always act normal to the cross sectional area. Okay, while this stress act normally and parallelly also. Okay, pressure can be measurable. Stress what cannot measurable. Without pressure, compression stress not generated. And here we can write there is no device to measure stress. The unit is same in both. Here unit is Pascal. Okay, unit is same in both. Or we can say Newton per meter square. Newton per meter square. Now we'll discuss about the quantities. Okay, so we know there are three types of quantities. One is the scalar quantity, and another one is the vector quantity. Okay, and the third one is the tensor quantity. Okay, so there are three quantities. One is the scalar, another one is the vector, and the third one is the tensor quantity. So here we know that in scalar quantity only magnitude is there. Okay, so in vector quantity there are magnitude and direction is there, but in tensor quantity has the magnitude and the direction and also the plane. Okay, so here you can see we get to know that scalar quantity has only magnitude, and the vector quantity has the magnitude and direction. M for the magnitude, D for the direction, and the tensor quantity has the magnitude, direction and also the plane. Okay, so here the same is the magnitude. The scalar has the magnitude, vector has the magnitude, and the tensor has the magnitude. Okay, that means these are the same. Okay, so now the tensor has two things. One is the direction, second one is the plane, and the vector quantity has the one thing, one is only direction, and the scalar has no thing. So here the tensor quantity has the two things, one is the direction and plane. The vector quantity has the one thing. Okay, and the scalar quantity has the zero things left. You can see in the tensor quantity it has two things, the direction and the plane, so that's why it is known as the second order tensor. Okay, similarly vector is the what, one thing is the direction, so this is the first order tensor. Okay, and scalar has the zero order tensor. So that is all about the quantities. These are the very important. So you have to remember these things. So thank you to all of you. See you in the next video.